Ladies and gentlemen, please welcome from Intel, Chief Linux and Open Source Technologist, Dirk Hohndel.
Good morning. It's always fun to be the third speaker in a series of keynotes. You see the massive departure of people who really need coffee or the opposite. Hey, been there, done that. So my name is Dirk Hohndel. I'm Intel's Chief Linux and Open Source Technologist. I've been around this Linux thing for a while, for 21 and a half years or so. And I've been a developer for as long as I can remember. I think I started working on computers something like as a 12-year-old. But today is really, really late. But back then it was an 8-bit computer with 3 kilobytes of memory. I said kilobytes of memory for the younger ones in the audience. It was very interesting to listen to the last two keynotes, because seeing how this event very much puts itself in the center of the data center revolution, the development of IT into a much bigger, much more all-encompassing plane, to me is very interesting. After all, this is an event that is focused on what fundamentally was started by an open source community, a community of hackers. And going from what used to be a community of hackers to an event of this size where I can't even see the back of the room, which is kind of nice, and an event that talks about the fundamental IT infrastructure that runs most of this world today is very encouraging to me. So one of the questions I often get asked when I say, hey, I work for Intel, I do open source. So Intel, what's with open source with you guys? I thought you make chips. And yes, when we are an IP company, everything we do is about our intellectual property, our ability to make better chips than anybody else. And we are a manufacturing company. We are a company that every year spends more than $10 billion in putting together innovations and new fabrication plants. We build these neat little big buildings, much bigger than this here, where we make the next generation of chips. Yet, we are also one of the top 10 software development companies in the world, which is something that most people don't realize. We actually have a significantly sized overall software team, and also one of the biggest open source teams out there. I usually keep joking the only company that is bigger in open source than us would be, well, obviously Red Hat. But in the latest kernel, we even surpassed Red Hat in the statistics. So we were the #1 contributor to the 3.9 Linux kernel. So why does a company like Intel, why does a hardware company do open source? Why do we think this is interesting? And especially given that we are so much of an IP company, a company that wants to own IP, control IP, and prevent anybody else from getting it. The reason is actually simpler to see once you figure out what drives our business. Our business is driven by people's desire to create new, interesting technology, fundamentally by innovation. Whenever somebody comes up with new, interesting ways to use computers, with new, interesting use cases, with new, interesting technologies, usually the first thing they do, well, the second thing they do, is they buy computers to run this on. So whenever we see an ability to accelerate innovation, to get people to do more interesting things in new ways, for us, this is something we want to enable. And this is where open source is actually, in many more ways, along our lines of thinking. Because open source means that this base knowledge, this fundamental tool set that everyone bases their innovation on, the ability to get a running start gets better and more powerful and stronger every year. So if you look at, let's go back 20 years. If you look at the tool set that you had back then, if you wanted to start, let's say, Facebook, and you took your Windows NT 3.5 server and your MS Access database and the batch file scripting language that you had at your disposal, and you started writing the Facebook web, oh, sorry, there was no web. Well, the Facebook Gopher client. I think that would have been pretty hard. And then on your portable phone, you remember portable phones? Size of a suitcase. On your portable phone, the user interface with ASCII graphics would have been a killer. It would have been a great product. Fast forward 15 years, and you have an IT infrastructure that is fundamentally based on open source, that is based on strong toolkits, strong SDKs, on the ability to develop a complete new industry that did not exist, based on open technology, with just the ingenuity of a few engineers, with a few ideas, but you get to something that then consumes hundreds of thousands of servers and hundreds of thousands, and actually hundreds of millions of client devices. What do all these things have in common? Well, they have a CPU on the inside, or usually more than one. So this long story hopefully explains why open source to us is important. Open source very much drives the innovation today, the innovation that gives us a lot of what then consumes CPUs, what then consumes the things that we produce as our main business. So we've been engaged, well, I have been engaged in Linux for forever, it seems, for half of my life. Intel has been engaged in Linux for about 15, 16 years, and from the get-go, this engagement, of course, has been with Red Hat, and we have been a very happy partner with our friends from Red Hat for a long time. This started with simple things like enabling the very first Xeon processors, and taking it from there to converting an industry that was in proprietary Unix risk jail for more than a decade. I'm talking about the financial services, about Wall Street, and taking this industry over to an Intel and Linux ecosystem that they are still on today. And taking it from the financial services as the first target market into more and more markets where running Red Hat Linux on an Intel server soon became what Jim Whitehurst said yesterday: you don't get fired for buying Red Hat. And so becoming the de facto standard in an IT industry certainly has been one of the rewarding results of the decade and a half of working together. And as you focus on the data center audience, it's interesting that over time you keep hearing the very same requests. They're often phrased slightly differently, but they're actually almost always the same requests. It's the question for performance. How can I make this run faster? How can I change my code? How can I change my tools? How can I change my setup so that this algorithm will run faster, this software will run faster? And again, if you look at the guys doing high-frequency trading, trying to ruin our economy, I mean, trying to gain more, whatever it is that they do, for them, it is a massive difference if this calculation takes 25 milliseconds or 26 milliseconds. Because if they can execute the trade a millisecond earlier, they'll make the money, and we all lose. So performance is a really, really important topic to these people. And then over the last decade, more and more we hear the question, oh, power is really critical. And then, of course, you talk to the engineers, to the developers, and you say, oh, we need to make this more power efficient. And they say, okay, let's optimize for performance. And you say, no, not performance, power. Well, it turns out it's the exact same thing. because your computer uses the least energy when it's not running, when it's idle. So it is a very good idea to get done with the running part as quickly as possible and get that thing to be idle. Or be able to run more things on the same computer, use fewer computers, etc. So the optimization for power that everyone asks for turns out to be very much the same optimization. So these are things that we've been involved for a decade and a half, making our infrastructure, making Linux, making the whole software stack run faster, run with less power, run more efficiently. There is a third angle that we hear a lot about from our customers, and that is what usually is called RAS, reliability, availability, serviceability, the ability to actually keep this thing running. And once again, the optimizations that you're looking at, the things that you're doing to make this happen, come from a very similar set of tools, because you want to reduce the fundamental footprint of your application. You want to reduce the points where failures can happen. You want to make sure that your infrastructure actually is resilient to things that go wrong. You do this in hardware. You do this in specific features in the platform that you offer. But this needs to be supported throughout the software stack, which is something that we have been very, very actively involved in doing. And as we go through, and Paul did this in his keynote, and I would have loved to actually steal his slide, that was very neat. If you go through this progression of IT from the physical server out into, well, my topic today obviously is the cloud, the next thing that happened was virtualization. And I was very charmed when Paul said that they were the first company that actually had virtualization, the hypervisor, as part of the OS. I would say, with a little asterisk to that, we were actually the first company that had an open source, hardware-supported virtualizer, hypervisor out there. So we were the folks who said, okay, if you really want to be able to do this well and do this fast, it needs to be in hardware. It needs to allow you a real abstraction of your operating environment. So let's go out, let's work with the Zen community and implement that. And then a few years when KVM came around, the same thing happened again. KVM will not work unless you have hardware support for virtualization in your platform. And so virtualization is a topic that has been near and dear to us for many years. And I'm always very excited when really new topics come along, when we have something to talk about that we never talked about before. So a couple of years ago, maybe it's 3 by now, the buzzword of the year was cloud. I'm like, awesome, what is it? Well, you have your computers and you virtualize them, and then you can kind of remotely deploy things. Yeah, we've been doing this for 20 years. And if you talk to the IBM mainframe guys, they will say, we've been doing this for 50 years. And so the more you talk about the cloud, the more you realize, oh, okay, so cloud is buzzword bingo for going back to the mainframe. Awesome, let's do that. Okay, maybe there are a few slight differences. I may be oversimplifying here. So let's not go too fast. We're not going straight back to the mainframe, and I'm pretty sure that 3270 terminals are not involved. Oh, we have old people in the audience. People are laughing. Awesome. I remember when I was the Unix architect at Deutsche Bank for a brief time, and I remember coming in the first time and sitting on a 3270 terminal and trying to edit a text. That's an experience. That makes VI look like a true innovation in usability. So cloud is actually a little more than the mainframe. Cloud is an idea that allows you to have the concept of a virtual resource, compute, storage, network, a resource that you can scale very quickly, very easily, that you can deploy either in-house in your private cloud or in a public cloud, which makes it a little easier for the NSA. We all hear we shouldn't tax our government too hard. But the idea is that you're able to do your computing in a fashion that does not require you to build a massive data center first and then hope that you grow, but you can basically burst out into resources that others give you. And especially when you start talking to startups today, in the last 5 years, the approach that startups have taken to what is IT for me, how do I build my IT infrastructure, has dramatically changed. Because to them, IT infrastructure is a MacBook and an Amazon cloud account. And that's often pretty scary. But on the other hand, you see more and more of the traditional industry players saying, cloud is actually a way of looking at my compute resources, at looking at my ability to deliver the IT needs of my internal customers, of my organization, in a much more organized fashion. And in a fashion that scales with their needs, that is easier to understand in how what I build them relates to what they get, and that abstracts out a lot of the crud that has accumulated in data centers. And I don't mean this in the form of hardware, but in the form of structure, of processes, of things that slow down innovation. I heard a very interesting talk a couple of times, because it was given multiple years, at OSCON about the idea of turning a data center into like a deli, into something that very quickly can deliver a product to you. And to me, this was kind of the predecessor of this whole cloud idea. This ability to say, I have a need, I need to provide a certain service, a certain application to an internal or external customer. I need to be able to build this, deploy this, run this, and support this, and ideally all this in the next 8 hours. And that is something that certainly 5 years ago seemed completely impossible, and that I'm pretty sure today half of the people in the room do every day. So, as you think about cloud as the core of the infrastructure that you work on, and as you think about what I said earlier, that to us open source is very much how we think of innovation and how we think we can seed innovation. Doesn't mean it's the only way of doing innovation, doesn't mean it's the only way of doing software. But to us, it's one that we think helps Intel bring innovation out into the market and helps the customers be able to quickly access new ideas, new technologies. So, cloud is becoming, or computing, or running your data center in the cloud, maybe let's phrase it this way, running your data center in the cloud is becoming the same thing that a few years ago running Linux was. When 10 years ago I would tell people I do Linux, and they would say, what's that? And then the easiest answer usually was, have you ever used Google, eBay, Amazon, any of those sites? Oh, they run Linux. Fast forward 6, 7 years, right now you say, do you have an Android phone? Okay, now you know what Linux is. And I think we will go through the same phase with cloud. If you are the vice president of cloud engineering of your company, and you meet the kids from your kids' school, the parents at soccer, and they say, what do you do for a living? You say, I'm vice president of cloud, and they say, oh, you're a meteorologist, right? So in very much the same way, I think we will see, as Linux has become so commonplace that actually now people at least think they know what I talk about when I say, oh, I do Linux. I think very soon this idea of a compute resource out there that is accessible to people, the cloud, will become something that people are much more familiar with, and that is commonplace. I don't think we will have a cloud-based phone anytime soon, because never mind. So the question is, what can we do to make success in the cloud easier for our customers? And we have been engaged with a lot of the underlying technologies for a very long time. whether it's the base kernel that drives the hardware, whether it's the virtualization layer that sits on top, whether it's the tooling layer to deploy the cloud infrastructure that sits on top, whether it's the networking layer that is part of all this. So we've been engaged in this for a very long time, and we have been an active participant in many of the key projects, for example, OpenStack. And we have done exactly the same kind of work that we have done in Linux for the past decade and a half in the cloud world. So for example, working on performance has been the obvious first thing for us to engage in. And here's one of those weird moments where you say, duh, because in order to improve performance, the first thing you need to do is what? Well, you need to be able to measure it. And it turns out that in the cloud world, one of the things that we didn't have enough of was good ways to actually measure the performance of what's out there. Being able to quantify, is this going well or is this not going well? So one of the things that we did a couple of months ago is we released a benchmark called COSBench, for Cloud Object Storage Benchmark, a benchmark that allows you to actually quantify how well your infrastructure is doing, how well it's optimized, how well it works for your specific workload. And we demonstrate this in our booth, I think this way, right? Yes, in our booth if you want to see this. But before you can optimize something, before you can work on performance, you first need to be able to measure it. So this is one of those key steps. Now, of course, the cloud in itself is of limited use. You need to always look at what is running there, what is my use case. And one of the topics that has been very interesting to us in this context has been big data, because there you really have this need sometimes to suddenly deal with much, much larger data sets, much, much larger compute needs than maybe you have provisioned for initially. So we have worked quite extensively on being able to run Hadoop on top of OpenStack. We actually have an Intel Hadoop distribution that is highly optimized for our platforms, including for the upcoming Ivy Bridge Xeon processor platform. And we have worked very hard on making sure that you can run this Hadoop distribution on top of OpenCloud so that you have the ability to do an elastic cloud for processing of unstructured big data. And this is one of the other projects that we are both showing in our booth and at the Cisco booth. For us, the ability for a customer to have a well-optimized software stack that runs on the operating system of choice, Linux in this case, and that runs on their hardware of choice and gives them the best possible performance is one of the key decision vectors that I think makes it interesting for you to look at Intel hardware. Another thing that is very important in this whole cloud infrastructure context is how do you deploy all this? So once you have your distribution, once you have your cloud infrastructure, how are you able to roll this out? How you're able to quickly respond to the needs in your infrastructure so that the cloud actually can show how flexible it is and how good it can do all this. So we have released the project Savannah together with our friends from Red Hat that allows you to provision Hadoop clusters across an OpenStack environment. So all this is really nice. All this is something that allows customers to be successful. But one of the things that I have been very worried about, especially in the past few weeks, but in general when it comes to cloud, is this idea of if my data, if my applications run in somebody else's data center, where is this trust is nice, control is better? Being able to know what is actually running on my images has been something that, to me, has always been one of those key worrisome factors. We talk a lot about, obviously, the private cloud, running the cloud in your own data center. But if you want to be able to use this ability to burst out and use outside resources to recover for peaks in usage. You have to have the ability to go into a public cloud and still trust that what is running there is actually what you're looking for, is the code that you wanted to run without anybody else listening in, stealing your data, modifying your data, whatnot. And so we've been working quite diligently with our friends at Red Hat and with the bigger OpenStack community over the last year and a half to be able to establish what is called the Open Attestation Project. So the ability to really have hardware-based verification that the modules that you're running in your cloud image really are the compute modules that you wanted to run, that the code that you have designated for this node is the code that is running there and nothing else. This is based on our TXT hardware extension and is something that is based in the root of trust of the device. So it's not something that software could falsify. The goal of all this is the idea to have an elastic cloud that is performant, that is cost sensitive, that is easy to manage, easy to deploy, and that allows you to run your workloads both in a private cloud or bursting out to a public cloud in a very flexible and very controlled manner. So where do we go from here? We've been working in the open source community for more than 15 years, trying to help create a better, stronger IT infrastructure. We continue to be very engaged with our partners and directly with the communities out there to create in open source and upstream, not in our own private world, but in something that is shared with everyone, and with a focus on what our customers really need for their data centers. And the goal is to accelerate your success in that cloud and to be able to have you say, yes, this is my cloud, and I run it with an infrastructure that I like, on a hardware infrastructure that I trust. Thank you.